All right, hello, welcome to a new video. So today we're going to do this problem called Design Hashmap number 706, and it is an easy problem. You can't really see me because I don't have any curtains, so like the exposure is kind of weird out. But anyway, so this was a problem that I had in my Uber call interview. It's not like a call interview, it's more like get on like Zoom or something, and then like yeah, it's not really like a phone call. I don't know why it's called. But anyways, so we're gonna solve this problem. Again, you can see that I did actually solve it, but this is really naive. And this is not really a hash. Well, it is a hash map, but it's like it's not a good one. Um, right? Because in hash maps we have to deal with collisions and like collisions, hash functions, right? So yeah, it's not a good one, but it is an okay solution, I guess. Um, yeah, hash maps are I mean hash functions are useful because like what if our input was not, or what if our keys weren't just integers, right? Like how would we like put it in this list? Oh, how would we put it in this list if it was like a string, right? Because we can't. There's no like, there's no index in a list where it's like a string, right? So yeah. So we're gonna solve this dealing with collisions and taking in for a fact that we're gonna use hash functions to like store these keys in like a list, right? Let's go do that. All right. So we started here. So we're starting from scratch. First off, let's go ahead and kind of go through my problem solving process. So we already know we don't really have an input or an output, so we'll just kind of skip that. Our whole focus is to code these functions up. I think um we're only going to focus on the plan, right? So for the plan, let's make a plan, right? So we're first going to have to make a hash function. So a hash function. And then in order to make a good hash function, we need to make it so that our hash function isn't bad, where it's like I don't know what bad a hash function is, but it basically puts a lot of keys in the same bucket or whatever for like some reason. But um since I studied this problem, um so I'm just gonna say that we want a very good hash function. And one of that way is to basically multiply the key. So multiply key, and then we want to get an index where it's in our range of our list. So we're gonna like modulo by size, right? So that's kind of it. And then I think for our to deal with collision, we're gonna have a collision, right? So we can solve this in two ways. We can either way is viable. But the one that I studied is that studied or just like notes on, is that we're going to we can make it into a bucket or a linked list. They're both the same idea, but a linked list in this case is what I'm going to use, right? Um, and so yeah, and in a linked list, how are we going to deal with collision? Um, in a linked list, right? We can't just basically say like, oh, okay, at this index in this bucket, remove it, right? Or just make it null or whatever. We're going to have to iterate through that. Um, so yeah, we have to iterate through the linked list and then delete it. Um, yeah, I feel like we can't really plan much. We just kind of like have to like go through like what data structure we're gonna use, like a linked list, and kind of like deal with that, right? So deal with it as we go. I think that's a good approach to do to solve this problem. Like if we did it raw, right? So since we're going to do a linked list, let's go create like a list node. So list node, and then in this we're going to have each list node is going to have a key value pair and it's next, right? So we're just gonna have a key and then value, and then a next. And we can say that okay, the key is gonna equal to the key that we're given. Same thing for the value. and the next. All right. Okay. So we created a list node, so we can just continue on with this problem, right? All right. So for the hash map, I noted that we're going to have like a multiply key. We're going to have like an integer that we're going to multiply with, and then we're gonna have a size, right? So I don't think our size matters. So we can just say like the size of our whole hash map can be like 1, 2, 3, 4, 5. But I also saw that making it like a prime number is also like a good thing to do. But I don't know any big prime numbers, so I'm just gonna do like 1, 2, 3, 4, 5. And then for the multiply number, um, what number? It can be any number to be honest, but I'm just gonna say like 6, 7, 8, 9. Right? To just go with the whole idea of like 1, 2, 3, 4, 5, 6, 7, 8, 9. You get it? Ah, funny. Okay. Anyways, so now we're going to create um our our data. So where we basically store our key value pairs in, right? So I'm just gonna say data, and it's gonna be a list of nuns when you start off by default, right? And then I'm gonna say, okay, we're gonna basically have this amount of nuns by the size. So this is gonna be the size of our whole data. So we can possibly have 12,345 unique key value pairs, right? Or locations where key value pairs can be in without having to be in a linked list, right? Um, so yeah, that's cool. All right, so in the put function, um, yeah, in the put function, that's where we want to basically um put new things, put in new key value pairs or update them, right? So let's go over this. So first off, what we want to do is since we're in a linked list and we want to update it, we can't really. Well, we can have like no, we 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 don't want to have any duplicates of the same list node. So what we're going to do is we're going to. I actually this is the wrong thing. We should make a hash function first, right? Let's see. That's what I should say. So we're gonna make a hash function actually. So hash. And then in this hash function, we're obviously gonna get the key we're supposed to hash out to get the index of where it's supposed to be in our data. So we're gonna be like, okay, so we're just gonna return the key. I mean the index where it's supposed to be in data. So we're gonna say the key is gonna be multiplied by the multiply by. Self that multiply by. And then modulo divided by the size of our whole data list. Right? And then that's going to return the index where it's supposed to be at. So now we can return to our put function. So again, hold up, let me go read it again. Okay. So inserts a key value pair. If the key already exists in the hash map, we're going to update the corresponding value. Okay. So in this case, we can't really update our list node. Well, we can, right? We can just make a function for it, like update, right? Or like set. We can have like a set function. But so let's just get like the hash it's supposed to be at, right? So we're gonna get the hash gonna be equal to um gonna be equal to the hash that we give it, right? The hash. And then at this point we have to oh actually um yeah we don't really have like a setter or getter function, so we're going to have to remove it first if it is in there. So all right, so we're gonna call remove with the key that we're given, right? Self.remove. And then once you do that, we can basically, yeah, so once we remove it, we can create a new list node for that basically. But first, let's go create a hash for it. So hash key. Okay. And so now what we can do is we can basically make a new list node. So new node is going to equal to the list node that we have. And then we're going to basically store its key and value pair in there. And then for its next, right? So I should have went over how we're going to implement this linked list, right? But I feel like it's easier to say like, okay, so you know how we started every index value to be none, right? So basically at so basically at um so basically at this index is a none, or is like a null pointer basically. So we can say that this new node points to what the head, but currently the head is none. But that's okay, right? So what we can do now is that we're going to make um the head of that index or that linked list the new node. So new node's basically the new head. So what this kind of looks like is that, okay, so all right, so we have, here's our linked list, right? We have null. We have null so far in our linked list, but we want to add, let's say, like a key value pair of like 2. Let's just say like it's 2, right? This is new node, right? So this is gonna point to null, but then we're gonna say, okay, this is the new head, right? Basically. So yeah, that's kind of what we're doing. So hopefully that makes sense. When we put, right, and hopefully that makes sense why we remove. Well, we could just like iterate. We could just like iterate and then find it, and then yeah, to like update, we could just like, instead of removing it, we can just iterate through the linked list, and then make like a setter function. But I feel like it's easier to just remove it entirely, right? Um, so yeah. So now what we're going to do is that I feel like our put function is completed. So we can just move on to our get function. Our get function is just basically going to iterate through the linked list, right? So we're going to say this. So there's could be some issues when we get. So we can say like, okay, so if, oh yeah, we first need to get the hash. So we can say, we can check the head of it first. So if self dot data at the head equals to none, or we can just say not. So if not, then we can just return -1. But if that's not the case, then we have to iterate through the um we have to iterate through the linked list, right? But I feel like instead of doing that, we should say like while the head. Oh no, we can say we're going to iterate through the linked list, right? So we're going to say node is equal to we're going to say cur node is equal to the head. So I thought I heard something. So we can say cur node is equal to the head. So data at h. So that data at h, right? Okay, so while cur node is like a valid, so while cur node is not null, we're going to iterate through it. So first thing we're going to do is we're going to check. So if cur node dot key is equal to the key that we're looking for, then we're going to return the value of that key. So cur node dot val, right? And then so basically, if that's not the case, where we never found it at all, I'm pretty sure in the thing it says that if it's not found, then return -1. So if not, then we're going to return -1. It's not found. And then for our remove function, this one's kind of a doozy, right? Let me think. So in our remove function, we basically want to remove it, but in a linked list, you can't really just say, okay, at this index, remove it, right? So, all right. So let's say we have a list of like linked list of 1 and 2, right? Um, and then of course in this case, in our case, that a 2 is gonna point to this null, and we want to remove 2. So remove 2. So we can't just remove 2 because that'll break the linked list. Because what if this null was like a 5, right? Right. So if we just remove this, then we're gonna lose like this connection of the linked list, right? Right. We're gonna lose this if we just remove 2, right? So we're going to have to do something. We're going to repoint basically. So if we want to remove 2, we have to make this 1 point to 2's next. So that's kind of our whole goal. But there's going to be different cases of how we're going to remove, right? So I can say, right, so first case, right? So the first case is going to be um let me think. So we're obviously going to get the key. I mean, we're gonna get the hash. So h is equal to the hash of the key, and then we're going to find basically where in that hash where our key is. So what I'm going to do is I'm just basically going to say, okay, so cur node is equal to the head of where we're at right now, right? And then let's see. So okay, so there's gonna be a case where we instantly see that our cur node is the key we're supposed to remove. So in that case, we can just say, if cur node is equal, no, if cur node dot key is equal to the key we're supposed to remove, then we're going to say, okay, so at the head, so the head now, because in this case we just got the head, right? So if cur node is the key, so basically if the head is the key that we want to remove, we're going to say, okay, so the head is going to equal to cur nodes dot next, right? So yeah, so the next should be null, basically. That's the case. So we're basically gonna restart this linked list. But in the case where it's not, right? You want to do this sort of operation where we find that where we find the node we want to remove, but we gotta remove it in a certain way. I know in our get function we said that while node, but in this case, right, if we get while node and then we compare if the node is the key that we want to remove, or if the node's a node that we want to remove, right? So if we're like right here, right, how are we going to do this operation where we say that the node before the thing we want to remove is going to point to the node we want to remove is next, right? So we gotta make our while loop different. So we gotta say, so like while cur node dot next, right? So while cur node dot next, so basically we look for if it's null or not. If the next is null, but in this case it's not. So when we say that, we're gonna be like, okay, so if cur node dot next dot key is equal to the key we want to remove, right? So we're at here, and we want to see if it's the 2. So if it's the 2, we're going to do this operation, right? So we're going to say that current node dot next is going to be equal to current node dot next, right? So we're basically doing this operation where we say, okay, we found 2. We're right here right now. This is our current node. So we're going to say that this guy's next, which is the node we want to remove. We're going to get that next and make that our current node's next, which is this red line basically, right? So then if that's not the case, then we're just going to increment our node. So current node equal to current node next, right? Yeah, I forgot we're going to turn from here. And then yeah, I think that's fine. All this looks like it makes sense. But I feel like the only way to test this out is to I don't have internet connection right now. Oh, I do have internet connection. So what I can do is I'm kind of lazy to just like make a test case for it. You know, I'll do it. Why not, right? Because it's good to practice. Always good to practice. So I'm gonna make a driver. I'm gonna pass it for now, so it looks good. But then now I need to import my I basically need to make a Hashmap object. So Hashmap, and then okay, so I want to basically put something in there, right? So let's just say um that put a key in a value. So let's say 1 and then like 1000, right? And then onto get, let's say like 1. I'm gonna print that out actually. Right, so let's see what happens. It should work. Okay, so there's an issue. Okay, so where's this at? H dot put self dot remove key. So key. Okay, put. Let's see. Current node dot key. So oh yeah, so none type object has no attribute key. Interesting. None type object has no attribute key. So if current node equal to key. This is in here. So if current node is equal to key. Current node dot key. So in this case, the current node is null, but we're supposed to get 1, right? Okay. No, okay, so we put. So we put it there. Okay. Then we do get. No, oh, okay, so we put. Okay. So I know the issue. So we did the remove, but when we first put, but we forgot to put like okay, so if current node If not kernode, then it's gotta return, I guess. Right. So this should work now. Okay, cool. So it works. And then I would say like h dot remove. And I want to remove 1. So it's gone. And then I'm gonna print when we do h dot get. Okay, cool. So it does work. So yeah, so that's cool. It does work. But let's see if it actually does work in the thing. So let me copy paste this. Cool. Then let me just copy paste my list node that I made. Boom. Now if I run it, it should work. Well, it works. So yeah. Now let's submit. Ooh. Index out of range. Was that the case? Or the index is out of range. How could that be out of range? Is there like, do I need like a bigger number? So it's saying that my kernode, it's saying that h is out of range. How could that be? Because we're doing modulo. Are we not? Do I need to do this first? Whoa, still. Why is that the case? So it's saying that h is out of range. Wait, how is that possible? Do I need to make the size bigger? Like 6? I'm actually so confused. Huh. I'm gonna figure this out. Okay, so there was a lot of issues that I found out after going through it. Um, but yeah, so I remember if you look back into the video sometimes, I would call the hash map. I mean the hash function, but I wouldn't I wouldn't call self. So we're basically getting, I don't know what happens there, but that was an issue. And also in this get function, I understand why we're getting time limit exceeded and stuff like that. Um, basically go into an infinite loop, and then what I need to do is that I forgot to say kernode. Go to kernode next. Like if we don't find it, right? So yeah, this should be better now. I'm pretty sure that's pretty much it of all the issues. And then I tried it out with this prime number stuff, but I'm gonna try it out with my own. 6789. So 6789. Let's see what happens. Okay, cool. All right, so that was the issue. It was just the self.hash, and then I went to infinite loop. So yeah. I don't really need to like review. But yeah, so this hash map, it's O of 1, but we have like O of n collision just in case. So for time and for space, it's O of n, like worst case. But yeah, pretty good. I learned a lot from this.